My voice is not clear. What can I do? I'm already connected to the wired network. I'm afraid there's nothing much I can do more. Okay. Now we will go through a design example. And in the design example, if you remember, we have to find out number of lanes. Through this example, you will see the procedure for the last part of your term project where you have to plot the speed flow curve. Okay, so there's a part of the project where you have to plot the curve yourself. So in this example, I will try to explain it. So try to be with me and do the calculations with me as well, as much as possible. So we have a new freeway which will go through a rural area. Hourly volume, design hourly volume is given. Obviously it should be in one direction. So you will get the number of lanes for one direction as well. So if I get 4 lanes, that means 4 lanes in one direction. Peak hour factor is given, familiar users, so no adjustment factor for that. Percentage of trucks is given, heavy mix means 70% big trucks. Total ram density is given. So now you are designing a whole highway. The entire highway may not have the same terrain. So we have discussed earlier, there can be different gradients on the same highway. In the previous example, the last example we did, we considered the gradient positive and negative for each direction. This one, we are considering 2 terrains. One is a level, the other one is a gradient. So the gradient one is a 2-mile section with 4.5% gradient. Okay, so if I go here, this one, okay, 2 miles length and 4% gradient, more than 3%. So this is fulfilling the requirement. Where is it? I don't know. Is my voice clear or not? No. I don't know. How does this happen? So I believe there's a lag. It's because there's a lag. Yeah. What can I do? I'm not saying anything. I didn't say anything. How is it now? Okay. Okay. So I believe there was a problem with the blackboard, I believe then. Okay, so if you have something like this, we can shift to Teams then. Okay, what can we do? Moving on. Where was I? Yeah. So they have 3 conditions for the terrain. We have level, we have 4.5% gradient, and who can tell me the third terrain condition here? There are 3 conditions of terrain in this question. One is the level terrain, the other one is plus 4.5%, and the third one is what? Yes, what third terrain condition is there? There are three terrain conditions given in this question. One is level terrain, the other one is plus 4.5%. Which one is the third one? Anyone? No one? Yeah, the third one is uh, huh? No. The third one is minus 4.5%, downward gradient. Okay, so there's upward gradient and there's downward gradient as well. One direction has upward, the other one is downward. So this is how we have three terrain conditions. Level terrain, upward 4.5%, downward 4.5%. Okay, and we have to find out level of service. Oh, sorry, we have to find out number of lanes. Level of service should be C or D. Level of service for this question should be C or D. Okay, let us start solving it. We start with calculation of free flow speed. Okay, free flow speed for a freeway equals this thing. Okay, from these things they have given me TRD. So TRD is 0.5. There is no question about it. Okay, it's very clear. Now the remaining things, I need lane width and letter clearance. Okay, I need lane width and letter clearance. They are not given here. Lane width is not given, letter clearance is not given. Okay, so what can I do? Then I need to assume, right? If it was an actual highway, assumption will not be valid. Okay, if it was a highway which is already operating, okay, it's already constructed, then my assumption will not make any sense. Why would I assume something which is already there? Okay, so you assume when the thing is not there. So it's a new highway and you are designing it. So after the design it will be constructed. So I can assume. Okay, it will be constructed once I design. So it's not there. So assumption can be made. Okay. Now which assumption should I make? This is up to me. Okay, so I'm doing it for these factors. This is a factor FLW, lane width. This is for letter clearance. Okay, so I need to assume a value from here and a value from here to get these factors. Okay, I know if I take any value 12 feet or more, and if I take any value 6 feet or more for letter clearance, the factor becomes 0. Okay, so I can assume that I will make the lane width 12 feet or more and I will make the letter clearance 6 feet or more. So the factor becomes, both factors become 0. Okay, so this is what I'm assuming. It's not given, and I'm assuming because it's a design problem, the highway is to be designed, so it will be constructed later, so I can assume. Okay, 0.5 was TRD which was given. Rest of the things are assumed. Okay, how much is it? Okay, so this is free flow speed. You should always start from here. Okay, now for number of lanes, the equation is this: peak hour factor, FHV, MSF. Okay, peak hour factor is given. Peak hour factor is given. Okay, FHV, let's calculate FHV. Okay, 1 divided by 1 plus percentage of trucks. I have 15% trucks. Then it is EHV minus 1. Now EHV depends upon terrain. I told you we have 3 terrain conditions. Okay, so let us do it for level. For level, EHV is 2. Okay, there's a table. I'm giving you the value from the table. Okay, so this will be for level. Then for downward, okay, so for downward 4.5% gradient, I have a heavy mix. Heavy mix is this one. This is heavy mix. Okay, 70% trailer trucks, 30% single unit trucks. 4.5% gradient downward. Downward means minus, right? Downward means minus. I don't have 4.5%. If you remember last time I told you, if you don't have the value or value goes out of the table, you'll take the extreme number. Okay, so the value 4.5% minus is out of the table. I will take the extreme number, which is minus 2%. Same thing for the length as well. I don't have 2 miles. I have only 1.5 mile. Okay, 2 mile is out of the table. If it was 1.3, then I can interpolate. Okay, if it was 1 minus 1%, I can interpolate. Okay, but if something is out of the range given in the table, I will just take the last value. Okay, so we'll take this value, okay, instead of 2 miles, and I will take a 15% trucks. I have factor of 2.04. So 2.04. Okay, then for upward, okay, do I have 4.5? So yes, I have. So I don't have to do any extreme here, but I don't have the length. So for length, I will take the extreme number. I don't have 2 miles here. Okay, again, if somebody gave me 0.95, I can interpolate between these two values. Okay, but out of the table, I don't interpolate. Just take this one, which is 3.11. Okay, so okay, so this will give you 3 values of FHV. That means we will have 3 values of N as well. Okay. Okay. So now you can see downward and level should be downward is negative. Downward is taken as negative. So 0.86 is negative, right? Negative 4.5%. Okay. So these two are negative. Oh, sorry, these two are equal. Level and downward are equal. Positive means upward. Okay, so this should be like this. Let me write it here. Yes, I will switch them. Yes. Thank you for telling me. hope you don't say anything like this to me for the exam. Huh? This answer was wrong, just switch it with somebody else. Okay, so this is your FHV. Okay, FHV problem is solved. Now the other problem is we have MSF here. MSF means maximum service flow rate, your ideal service flow rate for the level of service you want. Now you want level of service C and D. So I need to find out how much is maximum service flow rate for level of service C and D. This is where you need to pay attention, okay? And this is where we need this graph. I'll show you the graph, it's already plotted. So I need to plot this graph to get these numbers. Without the graph, the numbers will not come, and this is a graph which you have to plot for your highway as well, for your term projects as well. Okay, so let me show you how to plot the graph. Okay, first of all, you start with the axis, speed on the x-axis, speed on the y-axis, flow rate on the x-axis. Okay, speed, flow rate. First number, flow rate is 0, speed is free flow speed. Or I can write it here. Okay. Point 1, I have is x comma y, right? So 0, free flow speed. This is point 1 on the graph. 0 on the x-axis, free flow speed on the y-axis. This is how I got this point, the first point. Okay, now I need this point till when the graph is, straight line. Okay, so there's a point up to which the graph is a straight line. So I just need to know the speed. A straight line means speed is free flow speed. I need to know this one, the x value. Okay, so point 2, x value is called breakpoint. Okay, free flow speed I already know, we calculate free flow speed, right? Now we need to calculate the breakpoint. Breakpoint comes from here. Finally, breakpoint. Okay, so in our case, breakpoint will be what is 73.6? My free flow speed. Okay, I don't have any adjustments given. Okay, weather conditions not given, drivers are familiar, no incident, no bug zone, so there are no adjustments required. Okay, so how much is my breakpoint? Okay, so this is your breakpoint. So this means that point 2 is 1056 and free flow speed. This is your point 2. Okay, point 3, I will not call it point 3, I will call it point C, which is final point on the graph, the last point. Okay, I'm talking about this point. So you are here, breakpoint, I'm talking about this point. This point is capacity. Okay, so this point is speed, some speed, I don't know, and capacity. So first of all, I will calculate capacity. See, capacity is 2200, 10, free flow speed minus 50. Okay. Now how much is capacity? Okay, now this value is more than 2400. You see capacity has a limit of 2400. Okay, so I will not take 2436, I will take 2400. Passenger cars per hour per lane, just to refresh your minds about the units. Okay, so I took it because the calculated value goes above the range. Okay, now so I got for point C, I got C value. I need S here. Okay, from where do I get the S? From this equation. Why this equation? Because you can see capacity is after the breakpoint. So after the breakpoint, you have to use this equation. Okay, so my S 73.6 73.6 minus capacity, the one which I am taking, divided by DC, which is 45. Okay, why 45? You can see it in the graph, it's given. Now VP is, now understand this one because it will change later on as well. VP is the flow rate at which you are calculating the speed. Flow rate at which you are calculating the speed. The X value at which you are calculating the speed. For this point, I am doing it for point C. Remember, for this point. For this point, what is my X value? Capacity. So here for this point, I will put VP equals to capacity. Okay, only for this point. This is my break point. I have a power here. Power 2. Yes, okay, A 2. And then the denominator, capacity. Now this 2400 is because of capacity. This 2400 was because VP is also capacity. Okay, then okay, give me the value of S, and if you have any questions, let me know. Okay, so now I have point C as well. Okay, point C is capacity and this speed. Okay, so we have point 1, point 2, point C. I can almost plot this graph, but this is a curve. If I draw it with these 2 points, I will make a straight line. Okay, but you can see this, it should not be a straight line. I need to make it a curve. To make it a curve, I need more points. Let's say I need 2 more points here. Okay, I need 2 more points here. I know S can come from this equation for these points, and sorry, the S value, yes, the S value will come from this equation. But what about the flow rate? Okay, the flow rate should be between breakpoint and capacity. Anything between breakpoint and capacity can be on this curve. Okay, my breakpoint was 1056. My capacity is 2400. So anything between them can be on this curve. Okay, so I will take, for this example, 2 more points. Okay, so I can plot a curve. My choice is, I'm choosing myself. Okay, I'll call it point 3. Okay, at X 1500, and point 4 at X 2000. Okay, this is my choice. Somebody can select 1200, 2200, 1800. Okay, anything between the breakpoint and the capacity. Breakpoint is 1056, capacity is 2400. So any numbers between them, and you don't have to restrict to 2 points. You can make it 4 points, 5 points, 6 points. Okay, but if you join capacity and breakpoint directly, it will be wrong because it will be a straight line. Okay, so these x values are my flow rates, meaning these are my VPs. Okay, and I will use the same equation with these VPs now. So S at 0.3, the VP will change. Where is the VP? Here is the VP. Okay. Okay. So 0.3 will be the S value which will give me, and 1500, and 0.4 will be the value and 2000. Okay, so this one is 71.4 and 63.6. Okay, so let me summarize the numbers. 0.1 starting point was 0 and free flow speed. 0.2 up to breakpoint was breakpoint and free flow speed. Then this is 0.3 and 4 between breakpoint and capacity, and at capacity I have 53.3 and 2400. X comma Y, right? I'm doing it the other way now. Yeah. Okay, so you plot the graph joining these points. Okay, from point 1 to point 2 is a straight line. You have the same y value. Then from point 2 to point C, there will be a curve. Any questions? Okay. So I just explained to you how this graph is plotted. Okay, this is how the graph is plotted. Now the question comes how these lines are plotted so I can get the MSF for each level of service. For that, I will go back to the level of service ranges given by highway capacity manual. Highway capacity manual gives me level of service ranges for, I'm dealing with freeways, so I will use these ranges. Level of service C has a maximum of 26, D has a maximum of 35. Okay. This is density, 26 and 35 density. Density is flow rate upon speed. Density is flow rate upon speed. So this value is a tangent theta. 26 is the tangent theta and 35 is the tangent theta for this graph. Okay, because these are density and density is flow upon speed. So flow upon speed means it is the slope, right? What is slope? Tangent theta. Okay, so this is tangent theta of 35 and this is tangent theta of this line is tangent theta of 26 and this line has a tangent theta of 35. Okay, so this is how these lines are plotted. Once you know where the lines are plotted, you drop the perpendicular from there and you get these two values. Okay, so I need to know the slope of the line. Slope is what? The density. Okay, and from where the density comes? From the level of service ranges given by high capacity manual. So for this line, the slope is 26 for level of service C. For this line, the slope is 35 for level of service D. Okay, the slope is taken from the flow rate. It's flow rate upon speed. Okay, so that's why you can see I made the angles from flow rate. Okay. Any questions here? The angle should be from here. Sorry, the angle should be from here. These lines are just showing that taking from here, but the angle should be from here. This is my base, perpendicular upon base, right? So theta is from here. Theta is from here. Any questions? Okay. Once you have these values, I'll put them in the equation for n. Why we have three equations? Because of FHV. Remember, you calculated 3 FHVs. Okay. So that's why we have 3 n values. You can see all n values, and we are using level of service C, which is the best one out of the two. Level of service C is the best one out of the two. C is better than D, right? You all agree, huh? If you don't agree, I can give you C instead of D, or I can give you D instead of C. Okay, so C is better. So we are putting the best one here from the two given values or two calculated values, so we get the best answer. Okay, now you can see all answers are 2 point something, 2 point something, 2 point something. Okay, you cannot give 2.1 lanes. We are talking about number of lanes, right? I'm not talking about width of the lane. I'm talking about how many lanes. Okay, so if the answers are 2 point something, 2 point something, 2 point something, how many lanes should I give? Tell me. 2.1, 2.39, 2.1. You will give 3 lanes, right? More. Okay, can I round it off? You see all of them are close to 2, right? Why should I go up to 3? Why don't I stop at 2 lanes? If you round off 2.1, it is 2, right? So why should I go to 3? Even if you round off 2.3, you round off as 2, right? Why should I go to 3? 2.1 is close to 2. 2.3 is close to 2, not 3. We have to round up. Why? These are not your grades. Why should I round up? Okay, yeah, the safety issue for safety. Okay, you have the right idea here. So the point is, we round it up. Okay, but in this question, they gave me another option as well. I can go to D as well. I can see if I put 2108 here, the level of service D values, and I can see if I can just give up to 2 lanes or not. Okay, and most probably you will get answer less than 2 here. If you put for level of service D, the flow rate MSF value for level of service D 2108, you will get an answer which will be which will be lower than 2. Okay, so in that case you can provide 2 lanes, yes. Okay, but the point is, if I provide 2 lanes at the start of my design, then later on when the traffic will increase, the level of service will become worse than D. So I'm providing 2 lanes to satisfy D, not C. Later on, when the traffic increases, it will go worse than D, which will be not acceptable. If I provide 3 lanes now, I will have C now, and even later on, I will maintain C for a long time, and then even if it deteriorates, it will go for D, which is still acceptable. Okay, so that's why we took the best flow rate in this case. Okay, C. So even if I have some problems later on, which I don't know, or the growth rate is higher than what I know, I will still be on the safe side. Okay, so this is what you need to keep in mind. Okay, another question. We will try to solve it in a different way. So pay attention. We have a 6-lane urban freeway. Free flow speed is given. We have rolling terrain. Traffic 10% trucks. Standard mix. Standard mix means 70% single unit, 30% trailer trucks. This is called as standard mix. Okay. Smaller trucks are more, bigger trucks are less. This is standard. No adjustment factors. All conditions standard. Peak hour factor is given. Current volume is given. The current volume increases 6% every year for the next 20 years. So next year will be 6% more, then 6% more, then 6% more. The rate will continue for the next 20 years, not the value. Okay, the value is changing every year. By how much? 6%. For how long? 20 years. Okay, what will be the level of service for the facility now? And then after 5 years, then 10 years, 15 years, 20 years. Okay, now we have already done the level of service questions earlier. Okay, you can do it here as well. The only change will be you will do it multiple times because it is for multiple years. So I know that in the current year my traffic volume is 3600. In this case, free flow speed is already given. So step number 1 is already done. Otherwise, your step number 1 will be find out free flow speed, but it's given here. So for current, I will use the current volume. For after 5 years, I will use the volume after 5 years. For 10 years, I will use the volume after 10 years, and so on and so forth. What is the volume after 5 years? We have this equation from which it can be calculated. This is the equation to calculate future value when the annual growth rate is given. Okay, when the annual growth rate is given, future value of any entity can be found using this equation. Now, can someone tell me in which course you have looked at this equation, future value? In which course you have calculated the future value? Yes, anyone? In which course do you see this equation for calculating future value? Yes, I believe you mean the economics course. Okay, so yes, you are right. So let us calculate the future values here, okay, for each year. So I need the value for 5 years. Present value 3600, 1 plus I means the growth rate, annual growth rate 6%. I'm doing it for 5 years. Okay, so power of 5. Similarly, for 10 years, power of 10. For 15 years, power of 15. For 20 years, power of 20. Okay, so in this way you will have 5 volumes. Okay, V0 3600 vehicles per hour, and the remaining values which you will get from these equations. So V5 is how much? 4818. Okay, 10 is how much? 647 447. Okay, 6447 V15 8628 and V20 11546. Okay, you can go back and check and do the level of service analysis in the same way we did in the previous question using these values. Okay, free flow speed is given, so you will start from the step after that. But we have done level of service analysis using the V values earlier. So instead of doing it one time, you will do it with each V value. This is one way of doing it. Okay, another way of doing it is using the maximum service flow rate and maximum service volume. Okay, so for in the same way that we did this graph and we found maximum service flow rate for C and D, right? For C and D. In the same way, they have done these graphs for some free flow speeds, not all, some. So we are going to use those in this question. So they have done it for 65. My free flow speed is 65. So I can use these maximum service flow rates. Okay. So MSF for 65 level of service A 710. Okay, if you didn't know them, you will go back, okay, and you will draw the graph like we did in the last question. And in the last question, you just did it for C and D, the two lines for C and D. But if you have something like this and you don't have this table from where I'm taking the values, you have to draw the graph and make all the lines then for A, B, C, D up to E, all the lines. Okay, and then you will find out the values. Okay, this value is capacity. Okay, and the rest of the values will come from the lines. Okay, now I know maximum service flow rate means what? If I go, if I'm under 710, my level of service is A. Okay, let me go here. So this is the line for level of service A. If I'm behind this line, my level of service is A. If I'm in front of this line and behind level of service B, my level of service is B. Okay, so I can just look at the values, and if my value is more than this, okay, or if my value is less than this, I know my level of service is A. If my value is between these two, I know my level of service is B. My value is between these two, I know my level of service is C. So I can just compare and know what my level of service is. But can somebody tell me the problem here? Can I do this comparison? 3600 is more than this value. So my level of service is more than E. Can I do this? Can I start comparing now? Or is there a problem here? There is no problem, or we cannot compare. Why we cannot compare? The answer is correct. We should not compare, but the reason is more. No, so you are saying more than 2350 because you compared, right? When you say this is more than this, you do it after comparison. So you already compared. But my question is, can we compare or should we compare? Anyone else? The answer is correct. We should not compare. And the reason you can see if you look at what I have written in my last message, you can see the reason why we should not compare. If you look at these values, you can answer me why I should not compare between them. Yes, can anyone detect? Yeah, the units are different, so you cannot compare. Yes. Okay, so yeah, the comparison cannot happen because you cannot compare passenger cars with passenger cars per hour per lane with vehicles per hour. They should be in the same units. Okay, so to put them in the same units, I can convert these values or I can convert these values. Okay, let us convert these values. Okay, so all of them are flow rates. I need to convert them to volume. Okay, so first thing I need to, then I will call it maximum service volume at 65 for level of service A, let's say. Okay, so it is 710 flow rate. To convert it to volume, I must multiply by peak hour factor. Actually, the equation is here, given here. If, come on, too many slides, right? Okay, so I will multiply by peak hour factor to convert to volume, and then I will multiply with number of lanes and this thing to convert to this thing. Okay, so peak hour factor, okay, peak hour factor is given 0.92. Okay, so now it has become volume, and to convert the remaining, I need to multiply with number of lanes. Okay, number of lanes, there are 6 lanes, so I'll multiply by 3, one direction. Then I need to multiply by FHV. Okay, FHV, it's rolling terrain 10% trucks. Rolling terrain 10% trucks. I'm writing the equation directly here for FHV. Rolling terrain should be 1. Sorry, rolling terrain should be 3. Okay. Then for B, I just change this value. Then for C, I change this value. Then for D, I change this value. For E, I change this value. Where is E? 2350. Okay, so this will give me the comparable values then. These are the values I can compare with. Okay. Okay, the remaining D and E. Okay, so now we have the values, we can start comparing. Okay, my first value is 33,600. Okay, so it is between these two. This is for level of service B, this is for level of service C. Okay, so I crossed B but I did not cross C. Okay, so level of service at now is C. Then at 5 years, okay, my volume is 4818. Okay, where is 4818? So this was A, B, C, D. So I crossed D as well. Okay, but did not cross E. So it is E. Okay, then level of service at 10. My volume is 11546. I'm comparing with these values, right? So 11546, I already passed this one as well. I passed E as well. So after E we have F. And then 15 as well as 20. It's F. So A, B, C, D, E. Right? Six, 4, 4, 7, same thing. Yeah, 6, 4, 4, 7. Okay, we still pass F, right? We still pass E. Okay, 6, 4, 4, 7 is still more than this value. Okay, so yeah, my value is wrong, but my answer is correct. Same thing which happens in the exam. Okay. For year 10, 15 and 20, I passed the flow rate or the volume of the last level of service. So then I have F. Okay. This is how it is done. So it was C, then it went to E, then it went to F, and then obviously until you do something, it will remain F. Okay, any questions? Okay, let's say I want to avoid level of service F. Okay, so I want to know in which year I have level of service F. Okay, so I know a level of service F will happen in the future, right? It will happen in the future. Okay, so it will happen when the volume becomes 5405. When the volume crosses this value, my level of service becomes F. So in future, I'm looking for 5405. So I'm using the same equation now. This one, this equation. Okay, my F is when the level of service becomes F. My future value I'm looking for is Fn is when the level of service becomes F. It becomes F when you reach this value. Okay. So the present value I know given, growth rate I know, I need the n value. Okay, so when will I get to this value in future? So what is my n here? Okay, yeah, so almost 7 years, right? So any improvements should be done before the 7th year. Okay, so now it gives you the exact plan where it should be done. Okay, this is the graphical version of it. This is the capacity 5404, level of service E value, and these are your volumes. Okay, 3600 and so on and so forth. So you can know the graphical solution, you can do the graphical solution as well. So this is 5402. Okay, the volume, maximum volume at level of service E, and this is your volumes. Okay, 3600 and the values which you calculated from this. Okay, so you can do it graphically as well. Okay, so what can you do before the 7th year? Okay, what are the options you have as a traffic authority? What are the options you have? Some of the options are given here. You can try to reduce the demand of traffic. Okay, so it is 6% every year, which is very high for an area. So you can control the activities in that area. Commercial activities produce more traffic, so you can control the commercial activities, the licenses, the CRs for the commercial activity in the area. So if you control it, the growth rate will become less. So instead of 7th year, you may survive up to 10th year or 15th year or something. Okay, so this is called as zoning control. When you control the activities in the area, it is called as zoning control. You can increase public transportation. Okay, so this will also reduce the traffic growth rate. Traffic growth rate is the number of vehicles, right? So when people shift to buses, you will have less vehicles and more people in the buses. Okay, so now we have like one car and one person. So you will have one bus with 30 people. So you will have 30 cars less. So again, you reduce the traffic. You can improve other facilities. So people are coming to this highway, okay, because other highways are not good. So you can improve those highways, remove the signals, make bridges and so on. So you will still have the same demand, but it will come from different routes. And you can adjust the work hours. People are coming to this area for working hours. So this 3600 and the values which are given are for the peak hour. Okay, so when you will shift the working hours, the traffic demand, the peak hour will be less. Okay, so some offices start at 8 o'clock, some of them start at 9 o'clock. So the traffic will be distributed. So these are called as staggered working hours. So you can apply this methodology as well. Okay, some examples you should look into for practice from both editions, like I'll be doing. Okay, now we move to another uninterrupted flow facility, which is the 2-lane highway. Okay, so we have 3 types of uninterrupted flow facilities: multi-lane, freeway and two-lane highways. So we are now discussing two-lane highways. Still same outcome of the course. Two-lane highway means one lane in each direction. It may have a median, it may not have a median. Okay, so if it doesn't have a median, then people are restricted to do the passing or overtaking from the other lane. Other lane means other direction. Okay, so when people go to the other direction for passing, then it means that you are creating a safety risk and you may block the traffic from the other side. So that's why two-lane highways are very unique. You cannot, or we were not doing it with the other types of without the median, this can happen. With the median, there is no overtaking, right? So if there are two lanes, one in each direction, and you don't have a median, there is no overtaking. The other highways can allow overtaking. This one doesn't allow overtaking. So still, it is unique. Okay. Another thing is two-lane highways. The two lanes are very close to each other. We make two-lane highways on a small width of the land. So when two lanes are close to each other and they are going in opposite direction, they have an impact on the driver's speed as well. Okay, traffic close by traffic happening in a different direction has an impact on your speed as well. So if I see traffic a block in one direction and that direction is very close to me, we will have effect in my direction as well. This is human psychology. This is what they have found through many studies. Okay, these two-lane highways can have temporary lanes in special cases. For example, they may have passing lanes. So there can be portions of the highway where overtaking from the other direction will be more dangerous because there is no sight distance. Okay, so you may create a temporary third lane to let the passing happen for that segment. This is called a passing lane. Then we have truck climbing lane, which are on steep gradients. You have a steep gradient, the truck will go very slow. Okay, when truck goes slow on these two-lane highways, most of the traffic will try to go to the other direction to pass the truck. This is very dangerous. If one or two vehicles are doing it, you can control it. It's not so dangerous. But if everybody is doing it because of the truck, then you are creating a problem for the other side. Okay, so in those cases, instead of encouraging everybody to go from the other direction for passing the truck, you create a truck climbing lane. Okay, so you have a truck climbing lane, the truck goes in that extra lane only for that gradient part. Okay, and then you have turnouts and pullouts, which are basically when you want to get off the highway. Okay, so extra spaces for getting off the highway. Okay, you have a right turn, you have a facility, you have a garage, you have a what else, a fuel station, something. So you have a turnout lane, people who are turning. Okay, so if you provide a two-lane highway with an extra continuous lane, we call them 2+1 highway. This is very rare. Okay, but that extra lane is continuous then. The other lanes I was talking about, passing lane, climbing lane, turnout lane, plout lane, these are all temporary lanes. They are for a few meters and then after that they are gone. Okay, the base conditions, ideal conditions. Two-lane highways have these ideal conditions, which are very similar to what we have seen for freeways as well. Lane width 12 feet or more, letter clearance 6 feet or more, letter clearance, shoulder is part of letter clearance. Okay, traffic stream, all passenger cars. You remember the previous example, we are calculating maximum service road and passenger cars per hour per lane, right? So this is it. Level terrain, ideal, right? Level terrain is ideal. No curves. At curves you have a problem of sight distance, so no curve is ideal. And if you have a curve which is very big, still the sight distance is not a problem. So either the road is completely straight or there's a very big curve. What curve is very big? The curve which has a radius of more than this value. Okay, no impediments, is uninterrupted, right? Uninterrupted. Okay, so we have very few, we have no interruptions. If the interruptions are there, they are 2 miles apart and there are no access points as well. Okay, ideal is no access points. You have access points, yes, we can have access points, Okay, like we had for multi-lane highways, you can have access points, but this is not ideal. Ideal is zero access points. Good environmental conditions, visibility, weather, everything is good. Some examples. Okay, two-lane highways can be used for intercity travel. Intercity, you go out of the city, you are in a rural area, so population is very low. It can be used for intra-city connector roads. So from one part of the city to another part of the city, same city, okay, you are using it as a connector, okay, from one part to the other. There are some cities like this where the population is divided from one part and the other part. So there you can use it for connecting the two parts of the city, same city. Okay, and then there are locations where you go from a city to a far location. Okay, like you have a beach which is out of the city, or you have some industry, some factory which is out of the city. In some countries there are educational areas which are out of the city. Okay, just to control traffic and provide a green environment and so on. Okay, so in all these cases you can use two-lane highways. Within two-lane highways we have three types of segments: passing constraint, passing zone, and climbing and passing lane. Passing constraint means passing not allowed because of side distance. Passing constraint, passing not allowed because of side distance. Passing zone, passing is allowed because of side distance. You have side distance, you allowed passing, safe. Third one is passing allowed with an extra lane. So we don't have side distance. In the third case, there is no side distance. But we still want to allow passing because we know our drivers are wild. They don't understand. They will do the passing whether you allow it or not. Okay, so we allow passing and we provide a passing lane for it. Okay, so the third condition, first two conditions are very logical, simple. No side distance, passing constraint. Side distance, passing zone. Third one, no side distance, and extra lane is provided for passing. Okay, so there are three segments we have. I talked about access points. We discussed it for multi-lane highways as well. You have a right in, right out. Okay, no crossing, no signal. You can just enter the highway, right turn, or exit the highway, right turn. No crossing. Okay, and you don't have any signals or roundabout something. It's completely free. Okay, if you have a very low connection point, so there is an access point but the volume is very low, less than 20 vehicles per day. 20 vehicles per day is nothing, right? It's less than 1 vehicle per hour. Okay, so in those cases you have to ignore them. Access points which have very low volume can be ignored. Okay, if the two-lane highway has a median with a barrier, okay, so then that means that driver from one side cannot go to the other side. Okay, so it's strictly prohibited then. Otherwise, without median, there's a chance driver may enter and still cross. We will count it as an access point, by the way, because it has without signal or something. Okay, but you never know. The driver can enter, and because there's no median, he can still cross. Okay, so in those in those cases, they are saying that you count the access points only for one side. If they're the median, you count the access points only for one side. Okay, if there is not a median, then you count total, right plus left, total. Okay. Performance measures. Okay, I will discuss it next time. Okay, you have a quiz coming up next week. Okay, you can check the syllabus for the time. Okay, I will tell you the topics now.